Hello everyone, welcome to Enviro Pioneers. With this video, we are going to start the lecture tutorials of the noise pollution. वैसे तो noise pollution environmental science के syllabus में एक बहुत छोटा सा topic है, but still it is difficult to find the entire concept within a single book. This is the syllabus of noise pollution for UGC NET Environmental Science exam, in which we have the sources, weighting network, measurement of noise indices, noise dose and noise pollution standards, noise control and abatement measures, vibration and their measurement, impact of noise and vibrations on the human health. So we will cover all these concepts or all these topic in the following sequence of lectures, जहाँ पे हम बहुत बेसिक फंडामेंटल से शुरू करेंगे, बेसिक्स ऑफ साउंड वेव, देन स्पीड ऑफ साउंड इन डिफरेंट मीडियम, फिर साउंड प्रेशर लेवल को कैसे कैलकुलेट करते हैं, इंडोर एंड आउटडोर एनवायरनमेंट में साउंड प्रोपगेशन को कौन कौन से फैक्टर्स अफेक्ट करते हैं, देन साउंड और नॉइज में क्या डिफरेंस है, एंड देन व्हाट आर द सोर्सेज एंड इफेक्ट्स ऑफ द नॉइज पॉल्यूशन, मेजरमेंट्स ऑफ नॉइज पॉल्यूशन, एंड देन वो मेजरमेंट्स के बेसिस पे हम नॉइज इंडिसेस एंड देन ऑक्टेव बैंड्स का क्या इंपॉर्टेंस है उसके बारे में पढ़ेंगे, एंड देन हाउ वी कैन कंट्रोल और मैनेज द नॉइज पॉल्यूशन. सो हम बेसिक से शुरू करके एडवांस कंसेप्ट की तरफ मूव करेंगे. सो टू लर्न अबाउट द नॉइज पॉल्यूशन वी शुड हैव द प्रॉपर अंडरस्टैंडिंग ऑफ द साउंड वेव्स. तो जब हम वेव्स की बात करते हैं तो वेव इट इज अ प्रोपेगेशन ऑफ डिस्टर्बेंस फ्रॉम वन प्लेस टू अनदर in a regular or organized manner. So wave it is mainly of three types: electromagnetic waves, mechanical waves and the matter waves. So the electromagnetic waves are those which do not require a medium for propagation and they can travel through the vacuum also. For example, light, radio waves and X-rays. Then second category, mechanical waves which require a medium for propagation, means they cannot propagate through the vacuum. For example, waves on a string, water waves, sound waves, and the seismic wave. And the third type is the matter waves, which are associated with the constituent of the matters like the electron, proton, neutrons, atoms, and the molecules. Now, these mechanical waves are classified into two types: transverse and the longitudinal wave. So, the transverse waves, in which the individual particles of the medium, they move about their mean position in a direction which is perpendicular to the direction of wave propagation. It means अगर जो disturbance है अगर इस direction में travel कर रही है तो जो particles इस medium में है वो इसके perpendicular move करेंगे. तो जहाँ पे particles disturbance के perpendicular move करें, so that type of wave is transverse wave. And the second classification is the longitudinal waves, where the individual particles of the medium, they move in a direction parallel to the direction of propagation of the disturbance. So here we can see कि ये object की movement की वजह से vibration create हो रहा है, and the direction of disturbance is in this direction. अब यहाँ पे जो particles हैं they are moving parallel to the direction of propagation, but these particles are not moving from one place to another, but they are simply oscillating back and forth from their position of rest. We all are familiar with this type of graph, which is the representation of a transverse wave. And here we have few of the terminology which represent the basic properties of wave. So this is the direction of the wave movement, and this one is the direction of the transverse wave oscillation. So the highest point, it is referred as the crest, lowest point, it is referred as the trough. Wavelength, it is defined as the distance between the same point on the successive wave. So it can be the distance between two successive crests, it can be the distance between two successive trough, or it can be the distance between two starting points. Then we have the time period, which is the amount of time taken by the wave to complete one oscillation or one cycle, and it is expressed in unit of time, that is second. Then frequency is defined as the number of oscillations per second. So if we take a point, so how much number of oscillation it is passing through this particular point in 1 second, that is defined as the frequency. And then we have the term amplitude, that is the maximum displacement of a wave from its undisturbed position. So this displacement either towards the crest or towards the trough, it is defined as the amplitude. So understanding this concept for the transverse wave, it is easier because the particles movement is perpendicular to the direction of the propagation. But what about longitudinal wave जहाँ पे particles की movement parallel हो रही है, वहां हम कैसे crest और trough को define करें? तो उसके लिए पहले हमें sound wave समझना होगा कि कैसे यहाँ पे medium की movement होती है and how we define the crest and trough, और इस particular case में हम कैसे amplitude या frequency को define करते हैं. So this sound is produced by vibrating objects. अब vibration क्या है? This is simply a kind of rapid to and fro motion of an object, and this sound, it moves through a medium from the point of generation to the listener, and when the object vibrates, it sets the particle of the medium around it vibrating. अब इसमें जो पार्टिकल इमीडिएट कांटेक्ट में है इस वाइब्रेटिंग ऑब्जेक्ट के, तो सबसे पहले वो डिस्प्लेस होगा अपने इक्विलिब्रियम पोजीशन से, एंड देन इट विल एक्सर्ट द फोर्स ऑन द एडजेसेंट पार्टिकल. अब उसकी वजह से क्या होगा, जो एडजेसेंट पार्टिकल है दैट विल गेट डिस्प्लेस फ्रॉम इट्स पोजीशन ऑफ रेस्ट, एंड उसको डिस्प्लेस करने के बाद जो फर्स्ट पार्टिकल है वो वापस अपने ओरिजिनल पोजीशन में आ जाएगा, एंड जो नेक्स्ट पार्टिकल था वो अब किसी थर्ड पार्टिकल से कोलाइड होगा, वो फोर्थ पार्टिकल से, एंड दिस कंटिन्यूज इन द मीडियम टिल द साउंड इट रीचेस आवर ईयर. Thus, the sound waves are characterized by the motion of the particles in the medium and are example of the mechanical waves. Now, this medium of sound propagation is simply the matter or the substance through which this sound is getting transmitted, and it can be solid, liquid or gas. और जो सबसे कॉमन मीडियम है जिसमें साउंड ट्रेवल करता है दैट इज द एयर. सो ड्यूरिंग वाइब्रेशन, when a vibrating object it moves forward, it pushes all the particles which are in immediate contact with it, और उसकी वजह से क्या होगा, जो इसके सामने जो एयर है that will get compressed, creating a region of high pressure जिसको कहते हैं compression. Now these compressed particles will move away from the vibrating object, and they in turn will displace the other particles, and when this vibrating object moves backward, इट क्रिएट अ रीजन ऑफ लो प्रेशर जिसको हम कहते हैं रेयरफैक्शन, एंड इसमें ये पार्टिकल्स वापस ऑसिलेट होके इधर आते हैं. एज द ऑब्जेक्ट मूव बैक एंड फोर्थ रैपिडली, a series of compression and rarefaction is created in the air, and this make the sound wave which propagates through the medium. Now compression, it is the region of high pressure, while the rarefaction, it is the region of the low pressure. So this pressure is related to the number of particles of the medium in a given volume, and this pressure can be correlated with the density because the number of particles in a given volume, it is defined as the density. So the region of high pressure, it will be having the higher density of the particles, and then rarefaction, which is the region of the low pressure, that is related with the low density. Thus the propagation of sound, it can be visualized as the propagation of the density variation or the pressure variation in the medium. Here we have a speaker which is the source of sound. Suppose when it is off, in that case ये जो particles हैं ये equally और uniformly distributed होंगे, and then जो medium है इसका एक average density होगा या average pressure होगा. But when this speaker is turned on, in that case the vibration, it creates a series of compression and the rarefaction. अब जहां जहां पे compression है, it means the number of particles in a given volume that is very high. So in that particular area, the density is high and also the pressure is high. So the compression and rarefaction. So here we have the region of high density and high pressure, and the rarefaction, it is the low density and the low pressure. तो अभी जैसे हमने देखा कि sound, it can be visualized as the variation of the density and the pressure in the medium. So here it is mentioned that the density as well as the pressure of the medium at a given time, it varies with the distance above and below the average value of the density and the pressure. यानी medium का जो average value है density और pressure का, उससे या तो ज्यादा होगा या तो कम होगा. अब ज्यादा कहाँ पे होगा, जहां जहां पे भी हमारी रीजन ऑफ कंप्रेशन है at that particular point will be having the higher density, and जहां जहां पे भी region of rarefaction है, there will be having the low density or the low pressure. So the peak, it represent the region of the maximum compression where the density as well as the pressure is high, and the valley, that is the lower portion of the curve, it represents the rarefaction, which is the region of the low pressure and the low density. Now this peak, it is called the crest, while the valley, the lowest point, it is referred as the trough. So here these are the compression while these are the rarefaction. So the distance between two consecutive compressions or two consecutive rarefactions, it is called the wavelength, which is represented by the lambda, and the SI unit is meter. A sound wave can be characterized by its frequency, amplitude and the speed. So the frequency, it tells us how frequently an event occur. तो जैसा हमने transverse wave में देखा, so frequency it is defined as the number of oscillation passing through a point in 1 second. तो longitudinal case में भी same है. यहाँ पे जब sound propagate करता है through a medium, the density of the medium, it oscillates between a maximum value and the minimum value, जैसा हमने just इससे पहले देखा. तो change in density from the maximum value to the minimum value and again to the maximum, it makes one complete oscillation, and the number of such oscillation per unit time, it is defined as the frequency of the sound wave, which is represented by the mu, and SI unit is hertz. In this image, we have the representation of the same wave velocity but different frequency. So we can see that this particular object, because of its vibration, it is creating a series of compression and the rarefaction. But here, the distance between two consecutive compression, that is more. It means here we are having the longer wavelength. अब long wavelength है, इसका मतलब the time taken by the wave to complete one oscillation, that will be more, means the number of oscillation crossing from a particular point in 1 second, that will be less, and it is represented as the low frequency wave. जबकि यहाँ पे अगर हम देखें, it is having the faster movement, this particular object is having the faster vibration, and here also we are having the series of compression and the rarefaction, लेकिन यहाँ पे जो distance है between two consecutive compression, that is less, which means we are having the shorter wavelength. So the time taken by the wave to complete one oscillation, that will be less. It means कि अगर हम एक particular point को consider करें, तो number of oscillation passing through that point in 1 second, that will be more. So it is represented as the high frequency wave. So the time taken by two consecutive compression or rarefaction to cross a fixed point, या फिर अगर हम कहें one complete oscillation, that is called as the time period of the wave, which is represented by the symbol t, और इसका unit है second. अगर हमको frequency और time period को relate करना है, so it can be related as 1 by t. Suppose if you are attending a concert or any orchestra or simply listening to music, तो उस moment में several musical instruments are played at the same time. But still, जब हम इस sound को सुनते हैं, then we can perceive these sounds as the different sound. So this is due to the different characteristics which is associated with the sound. So pitch is one of its characteristics, यानी कि जो frequency है emitted sound की, उसको हमारा brain कैसे interpret कर रहा है, उसको हम कहते हैं pitch. The objects of different sizes and conditions, they vibrate at different frequencies to produce the sound of different pitch. The faster the vibration of the source, the higher is the frequency, and thus higher is the pitch. As we saw here in this image, here we are having the faster vibration and we are getting the high frequency wave. इसका vibration जो है वो थोड़ा कम है, and here we are getting the low frequency wave. So simply, the faster the vibration of the source, the higher is the frequency. Thus high frequency sound, it is considered to be having the high pitch, while the low frequency wave, it is considered to be having the low pitch. The next characteristic through which we can differentiate two sound wave is the amplitude of the wave. So amplitude, it is defined as the magnitude of the maximum disturbance in the medium on either side of the mean value, and it is represented by the letter A. So यहाँ पे amplitude, it defines the amount of pressure or density variation from the normal or the average density of the medium, and this depends upon the force with which an object is made to vibrate. The loudness or the softness of a sound, it is determined basically by its amplitude. If a wave is having the larger amplitude, it means it is having the louder sound, and if it is having the small amplitude, it means it is a soft sound or the quiet sound. So the loudness, it is the perception of the intensity of the sound which depends upon the amplitude. Lesser amplitude, quieter sound; more amplitude, louder sound. And pitch is the perception of the frequency of the sound waves. Low frequency, lower pitch; high frequency, higher pitch. Here we have representation of a sound wave. And if we change the amplitude or the frequency, the characteristics of the sound changes. यहाँ पे अगर हमने एम्पलीट्यूड इंक्रीज किया तो लाउडनेस इंक्रीज होगी, अगर हम इसका एम्पलीट्यूड कम करते हैं तो लाउडनेस डिक्रीज हो जाएगी, अगर हम इसकी फ्रीक्वेंसी को कम करते हैं यानी कि वेवलेंथ हमारा जो है वो इंक्रीज हो रहा है, देन द पिच इट डिक्रीजेस, and if we are increasing its frequency, pitch increases. In this image taken from the Shutterstock, we are having the example of the amplitude and the pitch. यहाँ पे एक लाउड स्पीकर है, so जो वाइब्रेशन क्रिएट होगी that will be with the maximum force. So we can see here we are having the high amplitude, so this is related with the loud sound. Here we are having a rat, so इससे यहाँ पे जो साउंड जनरेट होगा that will be having the low amplitude, so that will be quieter in comparison to this. अब यहाँ पे पिच का रिप्रेजेंटेशन है, सो विद इन 1 सेकेंड वी कैन सी द नंबर ऑफ ऑसिलेशन, इट इज वेरी लेस. सो लो फ्रीक्वेंसी, लो पिच, लो साउंड. तो यहाँ पे 1 सेकेंड में वी आर हैविंग द मेनी नंबर ऑफ ऑसिलेशंस. सो हाई फ्रीक्वेंसी, इट इज रिलेटेड विद द हाई पिच एंड ऑल्सो हाई साउंड. Next is the quality or the timbre of the sound, which enables us to distinguish one sound from another having the same pitch and the loudness. So sound which is more pleasant to us is said to be having the rich quality. Here we have the representation of the sound waves which are generated from 3 different instruments. So we can notice the change in the waveform. Waveform is simply the shape of the wave. यहाँ पे हम साइनोसॉइडल वेव देख रहे हैं. Here we can see the variation in the wave from this tuning fork. Likewise, इस इमेज में we are having 4 example: tuning fork, flute, voice and the violin, and all the waves are different from each other. तो जो साउंड जिसमें सिंगल फ्रीक्वेंसी होती है वो हम कहते हैं टोन, और जो साउंड which is produced due to the mixture of several frequencies, it is referred as the note, and this is pleasant to listen to in comparison to the sound having the single frequency. Next is the speed of sound, which is defined as the distance which a point on a wave, such as a compression or rarefaction, it travels per unit time. अब यहाँ पे एक sound source है which is continuously vibrating, and because of it we are having the series of compression and rarefaction. तो जो एक compression generate हो रहा है वो time के साथ एक पर्टिकुलर डिस्टेंस ट्रेवल करेगा, वो किस स्पीड से कर रहा है वो हम कैलकुलेट कर सकते हैं यूजिंग दिस फॉर्मूला, जहां पे स्पीड इज इक्वल टू डिस्टेंस डिवाइडेड बाय टाइम. अब वी नो दैट द वेवलेंथ ऑफ द साउंड वेव, दैट इज द डिस्टेंस ट्रेवल्ड बाय द साउंड वेव इन वन टाइम पीरियड. अब इस चीज को अगर हम यहाँ इस फॉर्मूले में रख रहे हैं, देन द स्पीड इज इक्वल टू लेमडा बाय टी. Yes, frequency is related with the time period with this formula 1 by t. तो ये इक्वेशन को हम फिर से लिख सकते हैं इस तरीके से, जहाँ पे speed is equal to wavelength into frequency. So for a given medium, the speed of sound, it remains almost the same for all the frequencies under the same physical conditions. In this table, here we have the speed of sound in different medium. So सबसे कम स्पीड ऑफ साउंड जो है दैट इज इन द गैसेस मीडियम, एंड देन उससे ज्यादा इन द लिक्विड्स, एंड सबसे ज्यादा इज इन द सॉलिड मीडियम. इन माय टीचिंग कैरियर एट द यूनिवर्सिटी, वन ऑफ माय स्टूडेंट आस्क्ड कि रबर जो है दैट इज आल्सो सॉलिड, बट स्टिल the speed of the sound, it is lesser in comparison to the other solid medium. So we will explore this particular concept in the next video कि क्यों sound का speed gas में या फिर air में सबसे कम होता है, and then why it is maximum in the solid, and within solid why we are having such type of variation. So we will cover this particular topic in our next video. For this video, the content for the concept have been taken from the chapters of the NCERT book. The link for these two chapters I will also mention in the description box. Thank you for your continuous support. We will meet soon in the next video. Thank you.